Hi everyone, welcome to my talk. Today I will be talking about the click that saves weekends. I usually refer to it as a magic click. My name is Tosho Trajanov. I'm CTO at Adiva. We are an exclusive developers network and we partner with companies to scale their engineering teams. We are a fully distributed network and we work with engineers from more than 20 countries in the world. On the bottom of the presentation you can find my Twitter handle. Feel free to reach out for any feedback, any notes. So during my engagement with Adiva, I got a chance to work with a lot of startups as well as Fortune 500 companies. And what I could notice is that majority of the companies are basically struggling to set up strong engineering processes. And when I say strong engineering processes, I mean deployment pipeline, QA processes, release processes, etc. Today, I'm here to tell you a story about personal story about a project that we worked on, and we were able to create one-click deployment in an old legacy environment. Setting up this one-click deployment helped us level up the project itself significantly, but also increase the developers' productivity as well. So to give you a little bit of an idea, a bit of a context about the state of the application we worked on, it was a legacy enterprise application built in PHP. It was being developed for over 10 years. It has 0% test coverage, and at the same time, it was supposed to work with multi-tenant environment, with single-tenant environment. It was really data-heavy. At that point, there were 10 engineers working on the application, but their enrollment was basically to keep the application alive. So there wasn't new features being developed. It was just to keep the application working as is. And at that point, everything worked smoothly because people were not really developing new features, but focused on maintaining the application. And real troubles for us really started popping up when the company got an investment and they scaled the team with 10 more engineers within 1 month, and then they plan to bring 50 new people within the next 6 months. And the problems we started facing with at that point were that the first one we were unable to ship. So you have 20 engineers, you are supposed to fix a bug or you are supposed to release new feature, but it just takes forever to put what you develop to production. The second issue we started facing with is we entered a phase where we have never-ending bug fix cycles. So because it's a legacy code, you fix something here and then something else breaks on the other side and you don't have a clue about why that happened. The full regression cycle was taking around 3 or 4 weeks. The releases were scheduled monthly, and because of the nature of the application, we had a few really big clients. We needed to do the releases during the weekends. So imagine if you have a scenario like this, someone reports a bug and you need to fix it, and if you want that bug to go to production, it should wait for at least 5 weeks or 6 weeks, depending on when the bug was raised, because after that bug is fixed, the whole application would need to go through a full regression cycle and then to wait for the next release drop for the people who are working on it to be able to release it. And I'm not talking about features, I'm talking about critical bugs. If you follow the pipeline, you would need a lot of time to release something. So at that time, we started thinking about this is a mess. The only beauty of the application was that it was making a lot of money for the company that was operating it. And I guess That's the main reason why we are still stuck with legacy systems in 2019. So we sat down and we say, okay, let's see what we can do. We started exploring a few alternatives about how we can get to the desired state. And one of the things we really get attracted by was the continuous everything. As an ultimate goal, the team said that let's try to do one-click deployment. And that was really good because the engineering team managed to agree on everything. But then when you propose this kind of solution to the management, this is the reactions you would get. People are just laughing. They are not taking you seriously because you have all of the processes, all of the engineering processes you have at that point are broken. And now you're trying to automate everything and come up with one-click deployment. Right, it's not feasible. But let's see why people are getting these expressions. So the objections we got at that point, the first one is the complexity. Everything comes with, so the management would say, instead of people working on actual features and developing the application, they would need to spend time on setting up the pipeline and whatever you're talking about. And that's true, but on the long run, setting up this kind of process would definitely benefit the organization significantly. The second thing that, the second objection we got is that it comes with certain risk, and that's true, that's right. People felt that if you're doing the deployment manually, you would be able to see what you're doing. And if something goes wrong, you should just stop the deployment and do whatever you can to stop the whole mess. While if you have a machine that's doing the deployment, people are really skeptic about it. The third objection we got is the control. Usually the managers and the product people are in charge for making decisions about when some features should go out and when some features should not go out. When you have one-click deployment and when you have a continuous everything process, the developers are the people who are basically making these decisions. And that's really hard because you need to sync the product and the developer to agree on stuff. And the last one is the habit. So you have application that has been running for 10 years. It was making a lot of money, and then you show up and say, you know, we need to stop whatever you were doing. We need to start doing continuous everything, and we need to have one-click deployment because whatever you did so far, it doesn't work. Which is right, but software engineering 5 years ago and 10 years ago, it's not the same as it is today. In today's world, we have agile. In today's world, the software is just evolving really fast. People are just releasing new feature to test the market and then shut them down. And if that was, so we live in completely different environment than what it was before. I will give you a quick brief of continuous everything before I walk you through the process we took to just get there. So basically, the whole development pipeline from setting up the goal to deploy, run, and monitor is handled by the continuous environment. Funny thing about it that on one of the AWS reInvent events in Vegas, it was compared to Nirvana, the state that's really hard for someone to reach, but once you reach, it's like that's the beauty of the engineering. That's the end goal of everyone. So the first step of continuous everything is the continuous integration. It starts with setting up the goal, goes through the design and develop and the build process. And continuous everything is basically doing incremental steps in the software engineering day by day to improve the software, to improve the pipeline, to improve all of the processes. And the continuous integration is basically a first part of it. The second part of it is the continuous delivery. So it's basically the continuous integration plus the automated tests and running them and listening to the feedback out of them. And then the last one is the continuous deployment, where you don't need to do anything manually, but the whole pipeline is being executed automatically. So you start from checking out the branch, then you fix whatever you need to fix, and then everything else is automated until it gets to production. One of the most important parts about continuous everything is that the code should always be in releasable state. And this means that even if you fix something, if all of the acceptance criteria, all of the acceptance tests passed, that means that you have a code, even though it might not be merged to the master branch and released to production, it's a state of code that could be integrated automatically, but in any point. Few other facts about the continuous integration is that it allows team, if something fails, it allows the teams to fail small. The second one is if something breaks, the break is so small so you can fix it right away. So there is no QA person to go back and create ticket for you and say, you know, this should be picked up, and then the team is sitting down to prioritize that. But if something fails, you would know right away because your build or your acceptance test would fail, or at later stage, the deployment to production. It allows teams to have fewer bugs. All of the bugs that are being located are usually located in the early stage of the development process. It allows teams to release new features quite fast. And obviously, it reduces the cost. So everything, all of this looks perfect on paper, but considering you have an old legacy state or legacy code and you have zero test coverage, the question is what could potentially go wrong if you dive deep into that and decide to implement it. The real question is what could potentially go right, because you have a massive environment, you don't have any tests. What's the starting point? How do you start to implementing all of this? We did a lot of planning about this. We did some dump steps, and I will go through each of them and walk you through all of the steps we took to get there. So the biggest problem we had at that time was obviously the legacy code. So you have a massive infrastructure, you have legacy code written in PHP, there are a lot of dependencies, and the code itself is even not testable at all. So we used the Wrangler pattern to be able to develop the new features, the new modules that were required by the product team. And we also use the branch by abstraction technique. Both of them are really well outlined by Martin Fowler, and you can read about both of them on his blog. So the Wrangler pattern basically, if you have an existing monolith application, we just added a dispatcher, and then all of the new modules we needed to develop as a part of the new feature request by the product were being developed on the side. So we said we won't touch the legacy part unless we need to do that. But all of the new features we are going to develop them as new modules, and then the dispatcher is basically going to open to work with them instead of the old legacy code. And as we were going forward, we were able to create a couple of new modules. So basically, the original monolithic application basically became less important. And as we were going through the process, I think in 6 months, we were able to basically get rid of maybe even 50% of the legacy code. The other technique we used is branch by abstraction. So we use this technique if we needed to, because we had the legacy, right? And then if you need to change the way some of the legacy components are working, what we were doing is basically introducing an abstraction layer between the monolith application and the new components we are building, and then the old components were slowly getting replaced by the new components. And obviously, even when we were developing the new modules here, and the new components using this technique, all of the code was written according to our development standard operational procedures. So all of the code was testable. All of the developers were asked to write unit tests, integration tests, and everything to make sure that all of the new code we are developing would comply to our bigger picture. The second issue we faced with, and it was maybe the hardest one and the most critical issue, is the automated test. So in the environment we work with, all of the testing was done by QA team, by a manual QA team. And then when you have an environment like this, you can see on the environment the manual QA testing, it first is taking a lot of time, it's not repeatable, and then it's really time consuming and it's really expensive. But if you look at bottom of the pyramid, you have unit tests, you have component tests, and you have integration tests, which are kind of less expensive to be developed on if you're looking into them on long run. So we put out a lot of effort in writing the unit tests and the components tests mostly, but we still kept some portion of the code. Let's say if there is some super huge, super big feature I'm developing, and then even if I write those tests, I still want someone to go ahead and manually check if everything is working fine. Funny thing about the automated tests at that point, because we didn't have a way to, or we didn't want to spend a lot of time on automating the legacy part. We said this legacy most likely won't be here in the next year. So if people use the legacy for 10 years now, and if the previous team solved most of the bugs that were part of this legacy, we are going to assume that the legacy is working fine. So if your legacy, we created a wrapper class and we said legacy return true, which means the tests are always going to pass unless we do some change in some change in that part of the code. So we utilize the previous techniques I mentioned to create new modules and increase the code coverage. And that was really helpful for us because all of the new code we were developing was testable. It was quite fast for us to run all of the acceptance tests and see if what we developed or what we are still developing actually makes sense and it's working as expected. The third thing that was quite challenging for us was identifying the pipeline. So the idea was every time you create a new branch, every time you create a pull request to master, the pipeline basically needs to execute certain set of actions to make sure that this pull request that's going to master is going to go through this detailed screening and would run all of the automated tests. So the first 4 steps in the pipeline are basically part of the continuous integration process. When you start the build, when you commit something, you trigger the build, and then if the build is successful, you notify all of the people who should be notified about the state of that build. The second steps were part of the continuous deployment. So if all of the tests run, if some people get notified, if the tests were successfully run, you just deploy to the server that needs to be deployed. That brings me to the next challenge we had, because you have an environment like this when the management says, okay, we are going to ship those 5 features next month, right? And now we are entering a stage where anyone who is developing a feature or anyone who is fixing a bug could trigger this deployment manually, right? So the question is, how do we ship features to production, but we are disabling them so the end users can't see them, and the management could enable them whenever they want to officially release that feature. So that we put a lot of effort on decoupling the deployment process from the release process. For us, the deployment was something that should be done by the technical team, by the engineering team, and the release is something that should be handled by the product people. The beauty of it is that if the product people change their mind or change anything in the acceptance criteria, that's not basically blocking the whole software engineering process. So there were a set of requirements, you did what you needed to do, everything is working perfectly, and then the product people are the ones who are going to decide whether this feature should be released to production today or tomorrow or next week or next month. Who cares, right? We use there is something called feature toggles that enabled us to do this. It comes with there are few ways on implementing feature toggles. The first one is dark launching, where you can put something in the code base. There is a toggle, you just disable it, and the end users or the product people or the people who should basically use the software, they won't see any difference. They won't see that feature. The next one is the phased rollout. And I think a lot of big companies are using the phased rollout lately. I know that Facebook is one of the advocates for phased rollout because it enables companies to ship features based on certain user parameters. So let's say you want to do A/B testing in Brazil, or you want to do A/B testing based on the device people are using, or whether they are beta testers or not. You can just ship the whole feature. You can just ship the whole thing and make it available only for a certain group of people. To give you a illustrative example about this, let's say you have 2 weeks delivery, and then you have feature A, B, C, and D that are supposed to start in the first week. You ship only A, B, and C, and you enable them for the users. But even though feature D is not completely done, if all of the tests were executed successfully, and if you got green light on the code that was developed so far, you can just ship that part of the code in week 1 and just have it disabled. Then in week 2, you can pick up what is left from feature D and put it together with the rest of the features that are supposed to be released in week 2. Another thing we put lot of effort in is the deployment strategy. We were playing with a few things when it was coming to deployment, because for us it was quite hard to identify what would be the best way for us to ship those new features. We used the blue-green strategy, or black-red, or A/B strategy. You can find it on internet. There are few different terminologies around it. And we also use the Kanuri deployment. At the end, we stick to the Kanuri deployment because for us it was less risky. So we initially started with Bluegreen deployment. When you have Bluegreen deployment, you have let's say, bunch of load balancers, and all of the load balancers are pointing to the previous code, to the previous version, and then when you do the deployment, when you do the switch, basically when the whole pipeline goes through, at some point the load balancers are switched and they are pointing to the code version 2. The beauty of it is that if you had code version 1 and then you want to, let's say you're starting the build to basically create the second version, the load balancer would still be pointing to the previous environment, and then when the build goes through and everything is successfully, the load balancer is just automatically going to switch to the newer server. And that's it's a good way of handling deployments, but the problem is that sometimes it's too intense, because all of the users are seeing your new dashboard, your new everything, and it's kind of more risky. But the next thing that the next deployment strategy that we were playing with is called Kanuri Deployment. So in Kanuri Deployment, you have a bunch of load balancers again, and then instead of updating all of them at one point to point to the new code, you do that incrementally. So you release you put only 30% of the load balancers to point to the new code, and then you're watching and you're basically following the error log and following how the users are interacting with the changes you did, and then incrementally you start updating the load balancer to put the traffic towards the new code. So that could take 1 hour, maybe 2 hours, depending on how much you would like to test and how confident are in your solution. We first started with Bluegreen Deployment, but at that point we were not really confident in what we are doing. So we switched to this approach, and this approach was lifesaver for us a couple of times, because if, let's say, your error log is getting filled faster than the previous server, than the old code, that's like a red flag for you that says, check it out, something is going wrong, and then you can just, if something goes wrong, obviously you can just say, okay, those 10% or 15 or 20% of the users that were getting the new traffic would need to go back to the previous state until we fix everything and make sure that everything is working fine. And in cases like this, if something goes wrong, only maybe the beta users or maybe only 10% of the people are going to notice that something went wrong, but you have still chance to fix that for the additional 90% of the users. The last thing that was kind of maybe even the hardest thing for us to fix or change is the mindset of the people we work with, because it's usually developers they don't care whether something will be released tomorrow or next week, and with this approach we kind of ask them to participate more in all of the phases through the development. So, and the effect was really good, because if you're a new developer, let's say, and if you fix a bug, then you can see your work in production in 30 minutes from now, because everything is automated. And that was kind of good trigger, because people really started participating more into the decision-making process, in how to optimize the pipeline and everything in between. Another thing is that the developers needed to learn that this is not a DevOps work only. So if the build fails, it means that sometimes it might be DevOps issue, but in many cases it's your issue, and you need to go back, see what you did wrong, and fix it on your own. And the last thing is that it allowed us to do continuous improvement day by day. So people were thinking, okay, how do we optimize this? Okay, how do we make this better? How do we speed up the pipeline? Why do we need to do static analysis on the code at this point and not later on? And they were able to understand the whole process from beginning to the end. And that was really great reward for us because everyone who was in the team was basically participating and was generating ideas that basically helped the engineering team, that helped the product team as well. So to sum up the actions we did to make everything automated, we wrapped up the legacy code. We use 2 patterns to just build the new modules, and we avoided touching the legacy part, the monolith application. We faked the automated test for the legacy. I'm not proud to say that, but for us at that point, it was the most reasonable way to get everything out of the door. We identified the pipeline. We decoupled release from deployment, which was one of the most important steps we did at that point, and we were able to create a culture of continuous improvement. There were the wins we got from implementing this process and optimizing all of the processes basically is that we entered a phase when we are able to release code on production even multiple times in the day if that's necessary. Production bugs were lowered by 80% because if you have pipeline like this, majority of the issues are being resolved and being identified earlier in the process. That also makes them less expensive because QA people, they won't need to go to Jira, create a ticket, then to go through the whole planning thing and prioritizing. From bug report to deploy without going actually on the server and hard coding, fixing all of the stuff, we were able to achieve 30 minutes time. And then that was the moment where we stopped working for during the weekends to do those releases. It basically increased the developers' retention. People were happier. People are fresh, etc. Before I wrap up the presentation, I want to give you kind of a quote. So it's always strive for continuous improvement instead of perfection. In our case, we could sit down and say, no, we are going to rewrite the whole legacy code and make it and make it just comply with the new standards. But we say, no, we are going to keep it until we reach a point like this. And it took us maybe 9 months, a year to basically get to a point where 80–90% of the new code is basically active and the legacy is obsolete, so we are not using it. But we did it that way. We didn't say, it's going to be perfect, we are going to recode everything. Same thing we did with the automated tests. So if you don't have the resources, if you don't have the manpower to sit down and recreate the code to be testable and sit down to write the automation tests, you just need to improvise. And once you start improvising, you get to a point where you can say, let's go back and see what we can do to improve what we have at this point. Thank you.
Okay, so this was a great talk. We have time for only one question.
Hello there. First, thanks for the great talk. And my question is really a small one. When you said that you preferred Kanuri deployments instead of Bluegreen,
right?
The diagram wasn't too clear. In the Bluegreen,
the Bluegreen wasn't clear?
No. In Bluegreen, you have the complete mirror of your setup, like roughly the same amount of instances, let's say,
right,
on the left and on the right.
Yep.
what's the percentage with, is there an increase of infrastructure that was used when you do the Canary, or you just use your current infrastructure?
We used our current infrastructure, but let's say if we had 6 load balancer at that point, we said we are going to release the new code. Only one of the load balancers is going to point to the new environment, and then if you have only one load balancer, you can just check in and follow the error log and all of the output that's happening. And if everything goes fine, you can put the second one and the third one, so you do that incremental.
Yeah, but behind the load balancers, you would have, at the time that you deploy, more instances than usual, or the same amount, and you just deploy the new version on the old instances?
You have so basically you need to spin up new instances to be able to build the whole solution and to be able to run through all of the tests.
Thanks.
Yep.
That was the question.
Okay, so once again, this was Tosho Trajanov. Thank you for your great talk.